There's only like half of you here, and you're still all so loud. What's going on? There's two things to be bad about. Which it looks like, I don't know, 50 to 60 of you here? Is that a good rough estimate? I have to watch how many lecture question submissions there are. There shouldn't be any more than 60. All right. Yeah, I'm surprised to see this so late today. WebSocket Handshakes is so fun. And I don't have a super ton of slides today, so we're going to do some demos today too. I might have time to do some of the demos that I didn't quite get to. Oh, I deleted my list. I always have to remember from memory what I was going to show. But let's do the slides. Anybody have questions before we get into it? Let's get into it. WebSockets. We're doing the WebSocket Handshake today. First, summary of Ajax. Let's motivate why we even want WebSockets, then what WebSockets even are, and then talk about the WebSocket Handshake. So Ajax, this is what we've been using so far to have kind of live interactions between users, but not really. It's not live interactions, but it does let us update content without requiring a refresh or any action from the user. We could have like a button that sends an Ajax request, not Ajax, but polling. We could have a button that sends an Ajax request and force the user to push that, but we advanced that to polling, where we have code that's going to send the Ajax script, Ajax request every so often. And the homework handout code is every 2 seconds we're going to send an Ajax request, which means for that live chat, messages could be up to 2 seconds late. You might not see the message until 2 seconds after somebody sent it, which for chat, maybe that's fine. I don't know. I like a really snappy, responsive chat these days. But for a lot of things, that's not going to suffice. We talked about long polling, which is a solution that works about just as good as WebSockets that we're going to see in a second. But we want a better way that's not going to require polling. We're not going to have all these Ajax requests. We're going to have something a lot cleaner, I think, in my opinion. We're not going to have all these long polling requests or polling requests constantly. So what WebSockets are full two-way communication, a full duplex communication, meaning that the server can send information to the user without the user sending a request. This is no longer request response like HTTP. We're going to open a WebSocket connection, and then client and server can send messages at will. The connection stays open. So we can get server pushes. This is something that we can't have with HTTP. We can't just send information to the user unless we set up something like long polling, which adds complexity, adds network traffic, adds overhead, adds all this stuff. With WebSockets, we can just send data to the user whenever we want. This actually gets us real time. I used to say like instant and stuff, and somebody made fun of me for it. I forget who, but I think it's one of my colleagues, another professor. It's like, it's not instant. You can't say instant. It's network delays. So real time minus network delays. Other than that, we're getting instantaneous communication between users, because it's however long it takes it to go over the network, which we can't get rid of that delay. No matter how much we try, we're always going to have network delays. So this is as fast as we're going to be able to get. And even that statement, somebody's probably going to say, well, technically, you can use a different. It's about as fast as we're possibly going to get over the internet. Without long polling, so we don't have all those long polling requests. We don't have all this extra overhead, all this extra stuff going on. And the way WebSockets work, what WebSockets are, is actually really slick. It's really elegant. It's kind of even dumb how simple it is. So we're just going to use the TCP socket. TCP is already full duplex communication. It's already two-way communication. We send and receive over this TCP socket already. And then we only use that to communicate HTTP right now. We expect an HTTP request. We respond with an HTTP response. WebSockets are going to say, wait a minute. Why are we restricting ourselves? We have this full two-way communication open with the WebSocket. With the TCP socket. Let's just use that and call it a WebSocket. So WebSockets really are just TCP sockets. Well, with some extra stuff, obviously, we're going to talk about in the next few lectures. But that's really what it is keeping the TCP socket open and using that for our WebSocket communication. That's what WebSockets are. So WebSocket, the protocol, how this works is first establish a TCP connection. We're already doing that. That's already what our web server does. We establish a TCP connection to speak HTTP. That's all our web server does right now. So what WebSockets does is says, okay, you only speak HTTP. All of your code is going to parse HTTP requests. You get information over the socket. You treat it as an HTTP request. That's all we can do. So with WebSockets, we start with an HTTP request. That's all we can do. We can't do anything else. That's not the way our servers are written anyway, the way we have them right now. So we start with an HTTP request, but instead of that request being a request and a response and then done, there's going to be a request that says, hey man, let's keep this TCP connection open. Let's stamp it and label it as a WebSocket connection. And then let's do WebSockets over this connection that we already have open, that we're already using to send this HTTP request and response. Let's just keep it open and call it a WebSocket connection. Deal? And then the server says deal. And then we have that TCP connection that was already open for the HTTP request, but we're leaving it open and calling it a WebSocket connection. We effectively upgrade that TCP connection that was used for HTTP and upgrade it to a WebSocket connection. And under the hood, like this, or conceptually anyway, this is how WebSockets work. And then we can send WebSocket messages over that connection, just back and forth. Server can push over that connection. Client can push over that connection. We have full two-way communication, live communication over that TCP connection that we now call a WebSocket connection. And that's WebSockets. That's really what WebSockets are. They're not like a really fancy brand new thing. It's just a creative, kind of elegant way to use what we're already using in a more creative way that has, well, we're not going to see this lecture yet, but on Monday we'll see that has really minimal overhead, like extremely minimal overhead with this communication. Our WebSocket's built on top of HTTP requests. I wouldn't say on top of, but it starts with an HTTP request. There's an HTTP request that says, let's change this TCP connection to a WebSocket connection. Once that connection is upgraded to a WebSocket connection, HTTP has nothing to do with it anymore. And any bytes you receive over the socket, over that TCP connection after it's been upgraded, you need to treat as WebSocket frames and not HTTP requests. Which is going to be one of the fun uses of a while true loop. We're going to write while true, keep receiving WebSocket frames. I always like when I can have while true and have it actually make sense. Then when the connection's closed, we'll have if the connection's closed, break out of the loop. That's how your code should look. We'll see examples of that in the next few lectures. It all starts with the WebSocket handshake. So that's the overview of what WebSockets are. Any questions about what WebSockets are, by the way? Because that's the concept. That's it. The rest is the nitty-gritty details that we're going to have to spend lectures talking about of how to actually accomplish this. So any questions before we get into the handshake? All right. Let's figure out how we're going to keep these TCP connections open. So we get an HTTP upgrade request that's going to say, hey, I want this socket to be a WebSocket connection. And we're going to take quite a few steps here, some very, very specific steps to make sure that we both agree that that's going to be a WebSocket connection. And then once it is, then we can start treating it as a WebSocket connection. This is going to make sure that client and server are both implementing the protocol properly. So the handshake is very specific, has very specific steps. That request, that HTTP request, the upgrade request, is going to have a few headers. These are the headers we need to be concerned about with our upgrade request. We're going to get a request. It's going to be a GET request. The path is going to be whatever we set as the path in our front end. So in our JavaScript, we're going to specify what the WebSocket path is. On our server, we're going to get a GET request for that path, and we're going to think, okay, I think this is a WebSocket upgrade request. You're going to see these two headers, connection upgrade, upgrade WebSocket. Notice the capitalization here. You do have to send these headers on your response, and I believe one letter off on the capitalization. Uppercase upgrade, and uppercase WebSocket, for example, I believe does break. I think it depends on the browser. So make sure you have your capitalization right. Upgrade is capitalized, WebSocket is not. And this third header, this is the one we are really super duper interested in. Well, what I mean by that is if you get a GET request for the path that you expect WebSocket upgrade connections to come on, I'm not going to be mad at you if you don't read these two headers. If you don't check if connection equals upgrade, if upgrade equals WebSocket, then this is an upgrade request. You can get away with assuming that those two headers are there. I'm not going to be mad at that. But this header you do have to read. The sec WebSocket key is going to have some random value. Value is going to be different for every single WebSocket connection, even from the same user. Same client, refreshing the page, it's going to be a different key. It's going to be randomly generated by the browser every single time it sends an upgrade request. You're going to respond with a 101 switching protocols as your response code. You're going to have these two headers, same headers that you got, same exact casing and everything. Some browsers will look for these, and if they don't see them, they're going to say, you don't speak the protocol properly. I'm not respecting this connection. And then secure WebSocket accept with an accept response. So this is the structure of the HTTP request and response. You're going to get this request. You're going to send this response, and then leave that TCP connection open. Do not let that TCP connection close. And that is now a WebSocket connection. The way you let a TCP connection close is what you've just naturally been doing all semester, is you let the handle method end. As soon as you get to the end of the handle method, that stack frame goes away, and away with it goes the TCP connection. That's going to get cleaned up by the library. TCP connection disconnected, tells the browser, hey, this connection is no longer open. Don't let the handle method get to the end. If it gets to the end of the method, TCP connection is closed, and there goes your WebSocket connection. So leave it open. Easiest way to do this, well true. You're never going to get to the end of that method. So well true, call your receive method again, get information from the TCP socket. Receive will hang if there's nothing to be read. So if you say my new data from my WebSocket connection equals receive socket.receive of 2K, it's just going to sit there. Your well true loop isn't going to spin around in circles. It's just going to sit on that receive call until the client actually sends a message. Then receive returns, and it'll go through all your WebSocket code, handle the message, do whatever you need to do, and then it'll go back to the top of your well true, and then hang on receive again. Since I gotten this far into the details, some of you have been seeing this. Receive, it'll hang until there's bytes to be read, and then it'll return any bytes that are available to be read up to whatever your argument is, 2K by default from the handout code. But receive will return an empty byte array if the client severed the connection. So some of you have like if received data, length of received data equals 0, return. Some of you do that as kind of a hot fix for the problem. But what that means is the browser is closing the connection, usually because it didn't like a response that you sent or just didn't like some way that you interacted with it. So that's a symptom of a bug somewhere in your server. But the client receive will return empty byte array if the TCP connection is closed by the client. So just a heads up, if you are seeing that, that's what's happening there. They didn't like something you did and just said, I'm done with this connection. Okay, so this is 20% of the WebSocket handshake. The rest of it, the hard part, the part that you'll I say hard, but it's not that hard. Tricky, maybe. There's a lot of subtle bugs that students like to write, so it can take some time. But the rest of it is, how do I generate this accept response? What is this accept response? It's going to be generated from this random key. You're going to take this random key, do some processing that we'll see on the next slide, and generate the accept response. So that's all that's left. That's what we have to do. But there's a very, very specific procedure in how to generate that accept response based on the random key. And this is it. All of it in one slide. So objective 2, the first part of objective 2 on your homework. Again, objective 1, we're done with. You can do that right now. I'm done with it in lecture anyway. Objective 2, it's going to start with the WebSocket handshake. And then once the handshake happens, you'll have to parse the WebSocket frames, which we'll talk about on Monday. So part 1, the first part of doing the WebSockets in learning objective 2 is going to be the handshake. And this is it. This is your favorite slide when you're doing that part of the assignment. So once you're ready to start LO2, I would pull up this slide. Actually, the previous one too. Start with this one. Make sure you have the headers and stuff right. But this we've been doing for 8 weeks. Been doing this for 8 weeks now. You know how to handle headers in HTTP. This is the new stuff. How do we generate the accept based on the key? Well, we're going to read that key header. That's going to give us that random value. We're going to append to the end, and this is real, this is really how it works. We're going to append to the end of that key this exact string. That exact string. This is in the protocol. The WebSocket RFC has this string. It says this is the string that we use. It's a globally unique ID. They generated this ID and said, this is the one that we'll use for WebSocket handshakes. So this exact string will appear somewhere in your code. When you're doing your project and you import a library to handle your WebSockets, somewhere in that library's code is this exact string. It's just how WebSockets work. This exact string has to be appended to the end of the key. Compute the SHA-1 hash of that. And whatever the SHA-1 hash is, base64 encode that hash, and that's your accept. It's a very specific procedure. Read the key, append that GUID, take the SHA-1 hash, and then base64 that, and that's what you set as the accept for the handshake. So very specific procedures. And yes, you can, we have to do SHA-1 and base64. You can use libraries for those. I'm not going to go over exactly the algorithms for either of those. Just pull in libraries. If I don't go over the details in detail in lecture, it's fair game to use a library in general rule of thumb. So SHA-1, base64, pull in libraries. So it can be as simple as 2 library calls and a concatenation, but getting that working exactly the way you want can be tricky. Yes?
So the GeoID comes, sorry, this is a really basic question. The GeoID comes is concatenated right after the key.
Yep. Yeah, it's subtle, but append versus prepend. So we're appending it to the end of the key. And I'll do an example, so we'll make sure it's 100% clear. Why? This seems silly. Why would we ever do this? This seems like a silly thing to code into anything. Why don't we just say, okay, send me a request for a WebSocket connection, and I'll just respond with, sure, this is a WebSocket connection now. Why go through all this stuff? 2 things. We want to make sure that we're speaking the right protocol. There's no possible way that somebody's going to send the correct accept by accident. So if a client gets the correct accept, they know, they're guaranteed. I mean, I'm not even hedging this one. Yeah, there's some minuscule probability, sure. But they're guaranteed that the server they're talking to does understand WebSockets. Somebody coded this up and sent the correct accept. We know we're both speaking WebSockets right now. There's no doubt there because there's no other way. How else is somebody going to get that exact right accept value? And 2, to avoid caching. This is a GET request. Oops, on the previous slide. This is a GET request. So some aggressive caching protocols might say, okay, this is a GET request. It should be idempotent. It should just be retrieving information. So last time somebody sent this GET request that looked exactly like this, the server sent this response. So I'm not even going to send this to the server. This is when you have like an intermediary, like a server, Nginx or Apache, or even a load balancer. Well, Nginx can be a load balancer, but something in between your server and your client that's going to process the requests. And then that might say, okay, I'm going to cache this and just send the response that the server sent back the first time without actually sending it to your server. We don't want this to happen. The whole point of a WebSocket connection is to keep the TCP connection from your server to your client alive. So we don't want anything in between saying, we're going to cache this, because then the request never even gets to us. There's no TCP connection to keep alive. It's not going to work. With the headers for the key and accept being different on every single request and response, that aggressive cacher that you don't want caching this stuff isn't going to have a chance to cache it. It's going to say, this is a different request, because the key is going to be different every single time. It'll have enough entropy that it's going to be different. The cacher has no chance, because it will be a different request. It'll have different headers. That's a different request. It needs to go to the server. It can't be cached. And we're not going to have caching headers that say this can be cached, of course, because we don't want it to be cached. So 2 big reasons why this handshake is the way that it is. Once the connection is established, and this is what we'll talk about on Monday, I'll just foreshadow it a little here, we're going to send WebSocket frames over this TCP connection. So there's going to be a very specific format to the messages we're going to send. It's not just going to be plain text or whatever, or just bytes. There's going to be a specific format to these frames with headers that we're going to parse in bits. We're getting all the way to bits. I'm excited. I might be the only one who gets excited at this part of the course, but I get excited. The first time I did WebSockets at this level, I was excited to do bits. The reason why, if you care, we learn a lot about bits in computer science. We take 191 and 341 and 220 gets into it a lot. We learn about bits, but it very rarely ever actually comes up. Like, you never actually have to know how to do a logical OR between 2 ints or something like that. Two byte or bit arrays, I guess, at that point. Rarely have to do any of that stuff. But with WebSockets, yeah, we have to get to the bit level. You have to understand and actually care that your integers are represented in binary, and we're going to use things like bit masks to extract the bits that we want, because we're going to have 1 byte, 1 8-bit byte that's usually represented as an integer, an 8-bit integer, non-negative integer in our code. And we're going to have to care that that's actually 8 bits and extract the bits that we're interested in, not just treat that as a byte. So that 191 knowledge and logic and exclusive OR, all that stuff, we actually get to use that in code. I get excited when I get to use something that I thought was kind of useless, that we actually get to use it in code. So I get excited about it. Y'all might disagree, but that's fine. And these bits are masked. I don't know why I have this bullet point in this slide, but on Monday, that's going to be very important to us. These bits are masked, which is going to be an XOR with a random key. And this is what the format, you're going to learn to love this format, or at least understand it. On Monday, we're going to go through every single bit of this, but just to foreshadow, this is each bit of the WebSocket frame, and we're going to see the meaning of every single bit in these things. Like, the first bit is the fin bit, then 2 reserve bits, then the 4-bit opcode. That's the first byte. So when you read from the TCP socket and you have this array of bytes, index 0 in that array, that's your first byte, is going to have these 8 bits. Byte 0 is going to have these 8 bits, a 1-bit mask bit, and then a 7-bit payload length. And then going through the whole thing. And that's most of it. And that's going to be the format of our WebSocket frames that we'll talk about on, not Wednesday, but Monday. This used to be a Monday lecture, and I don't know. It probably should have been, but because I had a lot of demos to do Wednesday, I could have done more of those today, but besides the point. Actually, then never mind. No, we're not restructuring the schedule right now. I wouldn't have a place to put the buffering lecture, was my problem with that. And masking, we're going to have a random 4-byte mask that's XORed with all 4 bytes of the message. We'll talk about this on Monday in more detail, but this is another prevent caching thing. It's something you'll have to live with. You'll have to do it in your code, and it's going to be kind of painful, remotely painful. And you're going to be like, why do I have to do this? This is another cache busting thing. So each message is going to look different because the mask, 4-byte mask, is going to be completely random every single message. So even if you send the same message multiple times, the frames look completely different. So no aggressive cachers in the middle there are going to mess us up. WebSocket's on the client, in the browser, client side. It's actually pretty straightforward. This is it. This is everything you need to know about client-side WebSockets, at least because we're using a library and the browser handles most of it internally. This new WebSocket, we're going to create a new WebSocket object. We're going to give it a URL, and the most important bit here is the path that we choose. I chose /socket here. So on my server, I'm expecting upgrade requests, WebSocket upgrade requests on the path /socket. I suppose now is as good a time as any to talk about this. This will be more relevant for your project than anything else when you're actually going to deploy on a server. But I'll take a quick time out and talk about it right here. This could be, you can do WS, so we're using the WebSocket protocol. We're not using HTTP for this one. // so I'm going to start the host and port portion. And I could put localhost :8080/socket. Like that's something that's going to work when you run your local tests, right? Don't do that. If I can encourage you, well, there's a lot of things I want to encourage you. So not one thing, but one of the things, if I can encourage you to do it, do this instead. Don't put localhost :8080 here. And the reason, I've seen this way too many times, I've done this too many times. So if I can get you to avoid that same issue, is you hardcode localhost :8080 here. Everything works on my laptop. I go to deploy at like CSE312.com, and it doesn't work anymore because it's no longer localhost, it's CSE312.com. It's not going to work. It doesn't work when I go to deploy. The website will load, everything looks fine, WebSocket connection's busted, I can't send WebSocket messages. If you do window.location.host and you're running locally, this variable is going to have localhost :8080. If you're running on CSE312.com, it's going to be CSE312.com. And your code is going to adjust to whatever your actual host name is. When you switch to port 80 or port 443, it's all going to update. Doesn't matter what the host is, you're getting it dynamically based on whatever host the HTML was requested from. So now you can move to any host you want and your code doesn't have to change. You hardcode localhost :8080 or you hardcode your domain name and then you want to deploy to a different domain name, you're going to have to update that every single time. Yeah. Do this always. Just always do this. Yeah, do this on both. It won't matter for your homework because you're building it, we're testing it, it's all localhost :8080, so it won't come up. For your project where you do have to deploy, is that out there yet? I think, because I didn't release part 4 yet, and I don't think I said this in lecture. You do have to deploy it to a domain name. Once you deploy it on your domain name, to avoid it works on my laptop, I'd go to deploy, and now the whole team's scrambling because you started the day before the deadline, and WebSockets don't work on the deployment. And avoid that. Do this. There'll be one less issue to worry about. But like I said, I've done this before. Now I know I don't do it anymore. But even after I was learning and I would still make the mistake, I at least knew what to look for right away. I would see that error, everything loads, but my WebSockets don't work. I know exactly where to look for that issue, especially when I'm on a team and other devs do that, which I have seen last year happen, as recently as last year. I know what to look for. I know what's going to happen there. So either make the mistake and then it's really ingrained in your brain like it is in mine, or never make the mistake and then you don't have to think about it ever until your teammates make the mistake, like later in the future. Hopefully not in this course, but in the future. So it's a common mistake to make. All right, so with that out of the way, this line right here This is going to send the HTTP request. This is going to initiate the handshake. Once this line of JavaScript executes, that handshake, it's firing off. You're going to get the request. If this were the only line in this JavaScript file, when this page loads, you're going to see an upgrade request on your server. You're going to get that HTTP request. You're going to be able to read the key. You can finish the handshake. You can respond with the accept, with the proper upgrade response, and create the WebSocket connection going through the whole handshake. Once the connection is established, once that TCP socket is now a WebSocket connection, you have a reference to the socket, and you have an on-message variable, instance variable of that socket object, which is a function. I'm going to set it equal. You can say equal function and write your function inline. Here I defined a function and set it equal to the function. I think it looks a little cleaner when you do this. But this is going to take a function. That function is going to take the message that was sent to you, and then you can process it however you want. I'm just logging to the screen right here with message.data. You're going to message object. It has a data variable, and that's where the actual message of the WebSocket frame is going to be, which the frame itself, that's going to be handled by the browser. Any masking that needs to be done, which actually is none for the browser, we'll talk about on Monday. But that'll just be the actual message that was sent, the contents of the message. All the other stuff is handled for you. And then to send, socket.send, and then whatever string you want to send to the server. And that's WebSockets on the client side. Send and on message, those are the two ways that you can receive messages and send messages. And the first line to create the connection to begin with. So window.location.host, I talked about that enough, but make sure you're paying attention to the path as well. Whatever you put here, this is the path that you need to listen for on your server side. So whatever, I forget what I chose, probably /socket in the handout code, that's the one you want to use. That's the path that you're expecting requests on for these upgrade requests. But if you change that path, which for your project, you'll choose what that path is, just be consistent what that path is. Client and server. Oh, I got ahead of my slides. On message takes a function, send the stuff. All the WebSocket frame, when you call send, this is going to be converted into a WebSocket frame by the browser. It's going to generate a mask. It's going to mask the message. It's going to do all that. You don't have to think about that client side. Server side, you'll have to worry about all of it. And again, this is the format that we have to be concerned with. Okay. Now, what I want to do, I got rid of my cheat sheet, so I have to remember. I know the first thing I want to do, but what I want to do first, and sometimes I do mess this one up, so if it doesn't work the first time, we will get there, is make sure we understand how the WebSocket handshake works, specifically the key and accept. I'm going to mute this because I've not done that before. And use actually I'll ask y'all, a website that you know uses WebSockets. The only one I can ever think of during lecture is Twitch, so I'll go to Twitch if nobody has one. But a website that you know uses WebSockets. Let's go to Twitch. No, there's no need. You only really need WebSockets if you need live, instant communication. So Twitch, their chat, I actually have to go to a channel. Twitch Rivals, sure. I have to go to a channel because chat uses ads. There we go. Problem solved. I'm going to refresh to make sure we have everything in the network tab. And chat does use WebSockets. It's the only part of Twitch that uses WebSockets. Their chat here. So let's look through all of our requests, which, by the way, any modern website, the number of requests to load the site is always phenomenal. I'm not going to look through here for the WebSocket connection request, but I am going to sort by status code, because then the 101s are going to rise to the top. So here's my chat.twitch.tv. That's going to be my WebSocket request. So this is what I recommend for testing. I'll probably talk about this again. Actually, I will talk about this again next Wednesday when I talk about WebSocket testing, but I'll do a bunch of it today too. When I look at this request and response, it's going to be the handshake. What I have right here is an example of an actual working, functional, correct handshake, WebSocket handshake. So when I see this, I'm thinking test case. I'm going to use this as a test case. Today, we're just going to do it manually. We're not going to use code for this. But I can see the request has the upgrade WebSocket, connection upgrade, and WebSocket key, the key being the one we're really interested in right now. And then a few extra ones, the WebSocket version and extension, which we're not super interested in. They're not required by the protocol. Oh, it's not what I want. I don't want any of that. Click the wrong one. All right. So what I want to do today, we're just going to do this manually, but I have this key. Oh my God. Discord. That's what I get for randomly clicking in panic. My expected accept. So the response has connection upgrade WebSocket. Oh, and the U is not uppercase there. There's a bug. Tell them, bug report. The U is not uppercase, so apparently you do get away with that one. At least in Opera. So here's my expected accept. Oh, if I can get the right thing. Too big. 36 is fine. So what I want to do is based on, that's the same value twice. I did, oh, that's the edit. I thought that was a copy button. Now I got to change the colors again too. $36. Okay, so with that key, that's the correct accept. That's what I need to compute. So I want to go through this and make sure I understand how the protocol works. I can be done with Twitch now. I got my test case extracted out of Twitch. Let me resize this and go to my WebSocket Handshake page. This is how I would do the code. Have this page open, have this slide open, and go through the procedure here. So I want to append this and compute the SHA-1 hash. And I'm going to do it manually. Of course, you would do this in the code to make sure that everything's happening the way you expect. But I'll save that for Wednesday. So SHA-1 calculator. Why it was on Twitch and not WS? It's similar to meeting HTTPS. Oh, and I did close Twitch. I would like to answer that question. Bless you. I don't know if I understand that question. But I do want to, there's something else I forgot to show. I wanted to show while I was in here. Oh, that's the question. On Twitch, it's the secure version. We don't have our encryption set up yet. Oh my goodness! Chat's open. Where's my WebSockets? And once the WebSocket connection is open, you can go to the Messages tab, and you can see all the messages that are being sent back and forth using WebSockets. I don't know if that was worth reopening it for, but it's good thing to know. All right, so here's my key. I'm going to append this exact value, which I'm going to have trouble grabbing, this exact value to the end without the quotes, and compute the SHA-1 hash of that. So SHA-1, that's my SHA-1 value. And then if I base 64 encode that, I should get to my correct accept. So base 64 encoder. And this, I do know what I'm doing, so I'll tell you right now, this won't give me the right answer. Encode, and I'm going to get some base 64 value that is not the value that I want. Computed accept. Let me add a space here to try to line it up. Those are the different values. When you're computing the base 64 encoding of the SHA hash, it's important to remember that the SHA hash is hex. There's clearly hex values here. We didn't just happen to randomly not get any letter past F. This is a hex value. When I open up just base 64 encoder, and if you're just pulling in any base 64 encoding library and not being careful about how you're using it, it's going to treat that as text. We don't want to treat this as text. We don't want to treat this as ASCII or UTF-8. I need a base 64 encoder for hex. So let me hex this, hex base 64 encoder. I should get one. I think it is the first result. I'm going to paste my hex value, convert. That doesn't look great, does it? Maybe it is. And we should get exactly the same value. So make sure you're using a hex base 64 encoder, because that's what your SHA-1 is spitting out, is hex. And we got the exact same accept. So that's confirmation. We're feeling good that we are going through the correct handshake to generate that accept, because we have a test case and we verified it. The next step would be to write a method that does that. And then write a test case, make sure you're getting the exact same value. And then on Wednesday, hopefully I can get through all of it, is going a step further and writing a test case that takes the whole HTTP request and generates a request or a response with the correct accept header set. I see way too many students wasting way too many hours by not doing those two things. So I'm going to make sure I get lecture examples and do that on Wednesday. Because without any of that, without testing this way, what students do to test, or what devs do, I mean, it's not unique to students. What devs do to test is they load up the page, they go to the network tab, and check the request and make sure it got a 101 response and didn't get any errors in the console. Which, if it doesn't go, that's good. If everything goes perfectly smooth, you can verify that it was correct. But if something goes wrong, you get no information about what went wrong. You just know something went wrong. And then what a lot of students, specifically students in this case, do is run to office hours and say, why isn't the connection working? So I want to prepare you all for that, prepare you with testing on Wednesday. We'll do that Wednesday. We got a few minutes. I can get something. Any questions on that, by the way, before I go on to something else? Oh no, all my stuff is here. Okay. Any questions before we go on to something else? I want to wrap up a few demos that I had prepared for last Wednesday. The WSS versus WS and HTTPS versus HTTP. We will talk about the differences of those, but not until we talk about encryption. The extra S, it means it's an encrypted connection. It's homework 4 is out. Homework 4 is pretty straightforward. It's one application objective, no learning objective test. It's just one objective. And it's to add HTTPS to your server. Actually, I don't think I added, I meant to add to that homework about WebSockets, change it to WSS as well. I think I forgot to do that. All right, let's talk about byte parsing. and really this comes with just one pretty simple warning, is /r/n/r/n. That byte sequence can appear in your code, in your request. So when you're parsing, and this is specifically for multi-part form parsing, when there's an image in there, we want to split up the headers in the body without destroying anything of the body and without converting the image into a string. What we want to do is find the first instance of this blank line, knowing that since it's a multi-part request, that we will have blank line sequences in the body of the request. So we don't just want to do split on /r/n, and we also have to do this in the world of bytes, not the world of strings, because we have to preserve that image. So how do we do all that? It's not too crazy. This is even more complex than it has to be. But let's first run this just so we can see what it's going to do. But we want to stay in the world of bytes. The request that you get, we're assuming this is the request. I didn't make an actual HTTP request, but just an example of text following the same structure, this is already going to be in bytes. Like you get it from the TCP stream in bytes in your code for your test cases. Put the B here, that's going to create it as a byte string, which is going to be an array of bytes. This is exactly how you read it from the TCP socket. So you get it from the TCP socket as bytes. So never convert it to a string. Just don't convert it to a string. Don't do .decode on this. Once you do .decode right here, you're converting that image bytes to a string, and you're going to get in trouble there. It's probably just going to throw an error and crash your server. So I want to look for this sequence, but I want to look for it in bytes. But I think of this sequence as a string